Hi, so this is my automated plant watering system using the Arduino, emergency stop button, temperature sensor, MOSFET, battery, the pump plus water, soil moisture sensor, the plant, and the multimeter. Temperature sensor because temperature affects how fast the soil dries. Warmer temperature dries soil faster, which explains moisture readings. The system is controlled by a Java program running on my laptop through the Fermata 4J library. Here in the main project, Java creates the Fermata connection and starts communication with my board. Here the sensor is reading dry since it's exposed to air because my plant is currently wet, so the pump turns on. On the laptop, the graph updates with the new moisture voltage, and on the OLED, the system shows the current state and the reading. Now, since I placed the sensor back into the plant where the soil is already wet, the system detects a high moisture level, as shown here in the graph. And also, this is what the OLED display shows. This is what happens when I use the emergency stop button. For CLO1, I used unit testing to verify the main logic in my program for the moisture and temperature conversion and also soil state evaluation methods. For CLO2, I used object-oriented Java design to organize the project into separate classes with clear tasks, which made the system more structured and easier to maintain. For CLO3, I used the Fermata-J API for communication between Java and the Arduino Grove board, and I used this API to control the OLED display. I used the OLED to display the plant current state, pump is on or off, moisture percent, temperature, and emergency stop screen. And then I used the Princeton std_draw to graph the sensor data over time. For CLO4, I used an array list of sensor record objects to store sensor data over time, and I also used that stored data for graphing, printing, and for CSV export. For CLO5, I used a state machine with dry, waiting, and wet states. The Java program uses conditional statements to decide the state from the sensor readings, and then it controls the Arduino hardware by turning the pump on or off. For CLO6, I found a timing error during testing where the pump was running longer than the 5-second limit. I checked the watering loop, found the extra delay causing the problem, I fixed it, and then retested the system.